Hello everyone. Today we shall discuss about this glass slab and I will show you how to find the lateral shift in case of refraction, right? We needed the materials like glass slab, various types of pins here you see, and geometry box. And in geometry box you'll find the compass, the scale, the protector and the set squares, pencil, eraser, etc. Right? Now I will show you how to find the lateral shift in a glass slab. Right? Let us draw this first. Let us first draw this outline of the glass prism, glass slab. First of all, we are drawing the outline of the glass slab. This one, this one, this one, and this one. Right? We have taken a point, a point. We have taken a point here, taken a point, a point here, a point, and we have drawn the normal here, that is O1 in 1, right? And if we put this one, this glass slab, right, and at 2 points we are taking 2 pins, one is green and another one is red. Let us put these 2 pins at point, 1 point here and another point here, red pin. Right? Now, here you see that if we measure the angle, we will find this is the incident ray, this is the refracted ray, and this is the emergent ray. Right? If we name it, if we find what is the angle of this incident ray, let us measure with the help of protector. Right? Here is a protector, right? We are measuring the angle of incident ray. Let us find what is the angle. Here you see that the angle of incident ray or angle of incidence is 10, 20, 30 degree, right? That means the angle of incidence is 30 degree. The angle of incidence is 30 degree. This angle we measure and got it as 30 degree. The angle of incidence is 30 degree. Right? Now, if you put this glass slab here, right, and taking these 2 pins, I put this point here, 1 pin here, green, and another red. Right? Now we'll take another 2 points. We'll take another 2 points, 2 pins, one is green, one is red, and put the pins in such a way such that if we see from here, it appears that they are in a straight line, right? Let us put 1 pin, green pin here, and another red pin here, right? Red pin here. Now, we will see whether if we see from this surface, this refracting surface, we can see whether these red pin, green pin, green pin and red pin are in a straight line or not. Let us find the from this reflecting surface. Let us find this one. If we see from this side, we will see whether these 4 pins are in straight line or not. Let us find. With one eye closed, you will see that all the 4 pins appears that they are in a straight line. Here see, here you see the red pin, green pin, again green pin, red pin appears that they are in one straight line, right? Let us find this one. One eye closed and let us find whether these pins are straight line or not. Here you see, it appears that all the 4 pins are in straight line from this refracting surface. Here you see, we are finding that all the 4 pins are in straight line from this refracting surface. You see this one? It is very clearly seen that all the 4 pins are in straight line. You see, first one is red, green, then again green, and then red. You see this one. These 4 pins are in a straight line. You see this one? It is fine. You see this one? All the 4 pins are in a straight line. You see this one? This position you see. You see? In this position you see that all the 4 pins are in a straight line, right? Now, here from this reflecting surface, we find that all the 4 pins are in a straight line, right? Now you see that. Now here you see. Now you see that we seen from this reflecting surface that all the 4 pins are in a straight line. Now if we remove this glass slab, and also remove the pins, and if we join with the help of pencil this point, with the help of this pencil, if we join this point, here I've joined, I have shown you how we are getting this point and this point. Here you see this point, right? And we are getting this is as the incident ray. This is PQ. PQ is incident ray. QR is the refracted ray, and RS is the emergent ray, right? That means this is the incident, refracted and emergent ray, right? And here angle of incidence we got at 30 degree. Angle of incidence, that is angle I, that is angle I. Here you see that angle of incidence, angle I, is equal to 30 degree. We got it by measurement. Now let us find the lateral shift. Now what is that lateral shift? Lateral shift means this incident ray, how much it shifts from its original path. Suppose there would be no glass there, it would travel in this direction, right? Since there is a refraction, the ray travels in this direction, that means there is a lateral shift of this distance. Let us find the distance of this lateral shift. Let us find how much lateral shift. Distance is, let us measure the distance. It is 0.9 centimeter. 0.9 centimeter, right? The lateral shift is 0.9 centimeter. Lateral shift is equal to 0.9 centimeter. Again we are explaining. Here you see that PQ is the incident ray. Here we are explaining that PQ you see that PQ is equal to incident ray. QR is the refracted ray. And RS is equal to emergent ray. Now let us find the angle of emergence. How much is the angle of emergence? Let us measure with the help of this protector. Let us measure with the help of this protector. Here you see, this is exactly 30 degree. 10, 20 and 30, right? The angle of emergence is also 30 degree. See, this is angle of emergence. This is also 30 degree, right? And we got the lateral shift as 0.9 centimeter, right? In this way, you have to find the lateral shift in a glass slab, right? Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.